Good morning, students. Today we will start with third class, which is representing the security fundamentals. So, under the security fundamentals, we are having three main topics. So, the first topic is input validation, and we will see an example for execution of how to do client side validation for this topic. That is the practical exercise for this class. And then next, second topic of security fundamental is attack surface reduction. And then the third topic is classifying and prioritizing threats. Right. So we will start with this class now. So the first one is first we will see what is security fundamentals. So this security fundamentals is required to build and maintain resilient web applications, right? So the core philosophy of this chapter is a single overarching principle. That means you should never trust a user, right? So that is the principle specified here. So the user should not be trusted all the time. So the first topic what we are going to discuss is input validation, right? So whatever input is fed by the user should be validated before it is touching the web server, right? So we know browser is our client side tool which is used to connect to the web server which is available in the internet, right? So before reaching the web server it should be validated. Whatever input through keyboard or mouse is fed by the user should be validated before it is forwarded as a request to the web server. So the first line of defense is ensuring that data entering the system is a safe, right? So the system specified here is a web server. So there are two primary strategies for this, right? Apart from the strategies, we are also having several techniques to represent this input validation. So the first one is blacklist validation, right? So this is the first one representing how we so blacklist validation, whichever sites or whichever URL should not be provided in the user from the user side, that will be blacklisted, right? So that is what a blacklist validation. For example, in an organization, if there is a fortified firewall that is installed in an organization, they will blacklist some URLs, right? So the URL should not be viewed by the student and the URL should not be viewed by the college. Like that, they will blacklist it, right? So whichever is not mandatory to be visualized, that should be blacklisted. That blacklist validation specifies the list of URLs or HTML encodings that should not be visualized, that should not pass through this web browser, right? So that is what representing this blacklist validation. So I will just go through it. This approach involves creating list of known bad inputs, right? So this is what I told, bad inputs. That bad inputs can be an URL or a HTML encoding and blocking them. So this is generally inefficient because it is impossible to predict every malicious variation, right? So because one first for a particular uh, uh, 2 or 3 months a particular virus or threat is very virus or any other URL is very much dangerous, and the attacker may invent any other URL apart from what you have blocked in the blacklist, right? So you have some certain, for example, if you are having four blacklist of URLs, right? And if there is any other threat is happening by any other URL or any other input which is not there in your system, automatically that will also lead to malicious variation of your output, right? So that is what they have represented. This blacklist validation is ineffective because we cannot identify whatever the malicious variation which is occurring in the internet, that will be included in the blacklist. If it is not included, automatically it will leads to vulnerability, right? So attackers can use different encoding. So these are the encodings, universal resource locator or HTML encoding to bypass simple filters, right? So the filters, whatever content which is not there in the simple filter can be used by the attacker to bypass it. So for example, a single quote used in SQL injection attack can be represent dozens of different ways, right? So in previous class we have seen some one or two examples, but there are more number of examples that are available in SQL injection to create the attack and to bypass the filters, right? So hence it is blacklist validation is ineffective. Next, we move on to whitelist validation. So this is somewhat effective compared to blacklist validation because we are going to provide whichever the content need to be passed, only the content, the URL or the encode HTML encoding, whichever is valid, only will be available in the list, right? So in the previous one, which is not valid will be available, but here in whitelist, only whichever URL you are going to use, only that URL will be available in the list, right? So that is known as whitelist validation, and this is the preferred method. Instead of looking what is wrong, we are going to look for only what is right, and only that right will be available in the whitelist, right? Example, a zip code must be exactly 5 digit. Anything that doesn't match the specific allowed pattern is rejected, right? 6 to 6. But so 5 digit based on the textbook what they have given, but normally in our countries and all the pin code is of 6 digits, right? So we can represent here as 6 digit based on our country, right? So anything that doesn't match the specific allowed pattern is rejected, right? So that is what I told. Whichever is right, only that right patterns are kept in this whitelist validation. Next comes client side and server side validation. So as I told you earlier, we are using web browser as a tool in the client side. So you can write code to do validation at the client side as well as in the server side, right? So client will send a request. For that request you will the server will generate the response, right? So this is a normal process which is occurring in the internet, right? So whichever the code what we are writing for the client side will check only what you are passing from the client side, right? So that is what client side, but client side validation will provide zero security. It will increase the performance as well as the experience, but it is providing zero security because an attacker can easily bypass browser restriction, right? So client side is only based on the browser too, so the attacker can easily bypass this browser restriction and he can try to access the server, right? So that is what are represented here as client side versus server side validation. So by seeing the zero security at client side, which is very much mandatory, server side validation is very much mandatory. So all security critical validation must occur on the server side, right? So so far we have completed 3 types of input validation: blacklist validation, whitelist validation, and client side versus server side validation. Next, we will move on. So we will see an example for client-side validation after completing the entire content of this course, right? So these are the commands that what I am going to execute while I am creating a separate file for that client-side validation code, right? Again, I am going to give an example based on Python Flask, right? So fourth one of input validation is excuse me, a regular expression which is represented as regex. These are powerful tools for matching complex patterns such as email addresses. However, they are difficult to write from scratch and can be vulnerable to regular expression denial of service, right? So that is what we are representing here as regular expressions. Using that regular expressions, you can implement that matching of validated sentences or matching of patterns. And if any other code which is not matched with this regular expressions will not be allowed to the will not be allowed as request to the web server, right? So that is the meaning of this regular expression. But it is difficult to write from scratch and can be from scratch, right? So we cannot do it from the beginning. That is what they have given here, right? And it will lead to vulnerable for regular expression denial of service, right? So this attack is possible if you are going with this regular expression representation for input validation if it is poorly constructed, right? If the expression is not configured correctly, it will be in a it will be in a weak state. That is what poorly constructed state that will lead to this regular expression denial of service. And it is recommended to use established battle tested regex libraries, right? So that is what we are representing here, because this will test whether the regular expressions is constructed strongly, and it will assure that it is not poorly constructed, right? So these are the 4 points that are discussed under input validation. So what are they? Just a recap: blacklist validation, whitelist validation, client server and client side validation, and server side validation. After that, regular expression representation, right? So the second topic what we are going to discuss is attack surface reduction, which is the second topic of security fundamentals, and we will move on to the second topic. So the attack surface refers to all the code and functionalities accessible to a untrusted user, right? Uh, so this code refers to that the place where the untrusted user's request can land is known as attack surface. So every feature added to an application is a potential new entry point from an attacker, right? So that is what represented here. So we will see what are the attack surface are available and how we are going to reduce them, right? So the first is the secure by default. We are going how to secure the attack surface by default. So applications should be secure by default, meaning non-essential features should be disabled, right? So whichever essential features only that should be enabled in the applications, and non-essential features should be disabled. Users should have to explicitly opt in to extra functionality rather than having to opt out, right? So that is what explicitly opt in. Whichever is mandatory, they have to opt in rather than having to opt out it, right? So that is what given here. The secure by default should be represented if there is unwanted features that are added, that should be disabled, right? So that is what given here. And then the second one is principle of least privilege. You should only provide user. So that is what already we have seen, right? So providing privilege is known as authorization. You should only provide a user or a process with a minimum permission necessary to perform its task. For instance, if an application only needs to read from a database, it should not have write or delete permission, right? So that is what example for providing least privilege, right? Because reading will not affect the content that is available in the database, writing will change the content, similarly deleting will remove the content from the database, right? So that means read is the least privilege from that is available in the database, right? So that is what principle of least privilege. With the minimum permission, it should start the task, and if it is required only, it has to grant the next level of permission. So next is minimize capabilities. So use the simplest programming objects possible, right? So the objects whatever is created by the user should be a simplest form, right? So that it will minimize the capability that will lead to the which will not lead to the attack surface, right? So if a simple data table is sufficient, don't use more complex data set that has extra unneeded features, right? So that is what represented here. Whatever is needed, only that is used. Do not include it, more data over there. So that data may lead to exposure of vulnerabilities, right? So that is what minimize capabilities. So that's all about attack surface reduction, which consists of three types of representation. Attack surface means the place where the attackers can land easily. So we have to reduce that surface such that the attackers will not have any space to go through that and then get the data, right? So next is classifying and prioritizing threat, which is the third topic of security fundamentals. So to effectively defend an application, you must be able to categorize and rank potential risk. So the sources outline several industry standard frameworks, right? So we will see several industry standard frameworks here one by one, and we will see how we are classifying the threats and how we are prioritizing them, right? So the first one is stride, stride. A classification system developed by Microsoft. Stride is developed by Microsoft, and it stands for spoofing, tampering, repudiation, information disclosure, denial of service, and elevation of privilege, right? So spoofing means we know how the IP addresses are spoofed such that the original the attacker's IP address will look similar to a original IPS address. Tampering means whatever content, the confidential content will be attacked and it will be tampered so that the original authorized user will get a tampered data instead of original data. Repudiation is also similar to that, right? So the content will be masquerade and the content will be changed by the attacker, and that will be provided to the authorized users. And information disclosure, confidential information, that is known as data breach, right? So data breach, confidential information which is private for the users will be made public so that unauthorized users can also visualize the confidential content, that is known as information disclosure. Denial of service, in previous class itself I told about DOS and DDoS. DOS represents that the attacker will create so many, they will flood so many number of requests towards the web application so that authorized user will not get the service at the right time, right? So that is known as denial of service. Authorized users are denied to get the service because of the request flooded by the attackers. And the DDoS is distributed denial of service, where the attacker's node will be available distributedly, right? So that is the difference. And next, last one is elevation of privilege. So this elevation of privilege, previously we have in attack surface we have represented that only least privilege will be provided to access to all the users, right? And if mandatory, based on the token passed, the access level will be increased. But the attacker will try to elevate the privilege which is provided in the basic level, right? So these are the threats, classification of threats that is provided by Microsoft, which is represented as stride, spoofing, tampering, repudiation, information disclosure, denial of service, and elevation of privilege. Next comes IIMF. It's a simpler model focusing on interception, interruption, modification, and fabrication, right? Interception is nothing but it is just listening, right? And interruption, it is making disturbance between the authorized user and then the web application. Modification, whatever content that is passed, confidential content that is passed between the sender and receiver will be modified by the attacker and sent to the receiver as a modified content. Fabrication and modification are similar. Fabrication is also original content will be fabricated to a different content and that will be passed to the web application, right? So that is what represented as the simpler model, which is known as IIMF: interception, interruption, modification, and fabrication. So next framework, CIA triad. So CIA itself, I think you know about CIA. Confidentiality, integrity, and availability is represented as CIA. So where confidentiality is nothing but keeping secrets, integrity means preventing unauthorized changes, and then that means the data should be the same. Whatever the sender is sending should be reached as same in the receiver side also. That is known as integrity. And availability, 24/7, right? So if you are an authorized user, you should get the service from the web application by 24/7. It should not be interrupted based on some attacks, right? So that is known as CIA triad, which is nothing but confidentiality, integrity, and availability. So next one is DREAD, DREAD. So it is an older scoring system for risk. D stands for damage, R for reproducibility, E for exploitability, and A for affected users, and D for discoverability. So it is now considered too subjective for reliable use. So it is an obsolete one. So next is CVSS, which is represented as Common Vulnerability Scoring System. So the current industry standard, it provides a framework for the current industry standard. It provides an objective numerical score based on the inherent characteristics of vulnerability, right? Objective numerical score will be provided based on the inherent characteristics of vulnerability, making it easier to prioritize which bugs to fix first, right? So that is what given here in the CVSS. So that's all about the classification of threats, right? So we have seen 5 classification: STRIDE, IIMF, and the CIA, DREAD, and CVSS, right? So why we are going for the why we have gone through this 3 types of security fundamental, three topics which are coming under security fundamentals, because validation like a security validation is like a security checkpoint at the airport. So blacklisting is like list of specific individuals who are not allowed to fly uh, in the aircraft, right? So using fake id or any other fake information, they should not be passed through. Whitelisting is providing a valid passport as well as valid visa that matches the bordering of pass, and if you don't have exactly the required good documents, you are getting on the plane, no matter who you are, you will be rejected as an unauthorized user, right? So this is the analogy for security fundamentals, and we will move on to the practical session, how we can implement the client side validation. So with this, I think we are completing unit 1. So I will move on to the demo session. So for this demo session, let me show what are the folders, what are the content I have created, right? First, I will show the folder content. Then we will move on to the coding part. Then we will start executing that coding part. Okay. Okay, so if you see here, I have inside web apps lecture, I have created client validation folder which is the folder which is used only for this programming content for client validation. Within that folder, we are having one Flask application, that is Python Flask program, and one folder which is represented as template, and I have created a virtual environment to execute this uh, file, right? So that is what VENV, which is nothing but a virtual environment for client validation. And let me start displaying the content of this app.flask folder. Then we will move on to the HTML file which is available under this templates. Okay, so this is the Python Flask file, which consists of so here we are importing the Flask package, and within that Flask package, whatever package we need a render template request. So whatever you need, you can include this for this particular package, and then we are defining the object for the Flask app is equal to Flask double underscore name double underscore, and then we are creating the path route for that, that is endpoint is created, which is nothing but the API endpoint. So where app.route is equal to, so this is the default path value, and methods, here we are going to use get method and post method. So get method is going to display a HTML file where you have to feed your information, and post method is to post that content into that actually what it is going to do, we are going to do it only in the client side. We are not going to post it in the database which is in the server side. So this post method just it will post the content and display a message, whatever message you are passing here, that is the message what we are going to receive through post is the name what you are entering in the name field, and email what you are entering in the email field, that will be displayed as the message if post method is clicked, right? If submit button is clicked, right? Okay, so we are defining a method which is index. So this index should be the name of the HTML file what you are placing inside the templates folder. So we are defining the method def index, that is function, and then the message, we are creating an empty message. If request dot method equal to post, then it has to retrieve the name what we have created in the HTML file. That name of value will be retrieved. Similarly, this email variable will retrieve the value from the HTML file, which is where you are feeding the email value, that will be retrieved to this, and this message will combine these two values, right, name and email, and it will print received the name what you are entering as well as the email what you are entering, right? And then it will return render template index.html. This is nothing but the file what I have written in the HTML. I will show it to you, and this file should be kept under templates folder, right? And then message is equal to message, right? So this message will be passed over here and it will be rendered in the template, and that will be displayed in the web browser. And then we are start executing this file. If name equal to main app.run debug equal to true, already I told what is the purpose of debug is true, because whatever errors or warnings, it will give a descriptive representation of that errors, right? So that is what debug equal to true. So now we will move on to index.html file, right? So here this file consists of HTML tags. We are opening a HTML file, and head and body. This is the head tag and this is the body tag. And we are keeping the script inside this head tag, and body consisting of labels along with text input. Similarly, one more label text input and a submit button, right? So I think you know about this HTML part. So I'm just going through this validation part at the client side using the script. So with that script tag, you have to start the function validate form and let name equal. So here what we are representing, we are getting the name value of the name from this form. What name we have provided here, same name should be used here to retrieve the name of it, right? So document dot forms my form name dot value. Similarly, we are retrieving email from that email field, right? So the from this email name what we have given, we are retrieving the value of it and we are storing here as email. So these name variable and email variable will have the value whatever you have entered in the text box, the text box what we have represented here, right? And if name dot trim, so that means if you have not given any values to the name, if it is null, automatically it will send an alert name is required, right? So automatically it will not allow you to submit button. If you click the submit button, it will give an alert that this field should not be empty and it will return false. So next, if email dot includes is not having at symbol, only at is checked here, but you can check dot com or the subdomains, domains, everything you can check it. But here for simple example, I am checking, I am validating whether the input of the user is having at symbol or not. If there is no at symbol, automatically it will represent, you have to enter a valid email and then it has to return false. So if you are when you are returning when you are typing the valid email, that time only it will return true, otherwise it will return false, right? So and then after all these conditions it will return true, which will allow for submission if you click on that button, submit button. Is that clear? And then this is the message what we are passing through it, and that message will be displayed in the web page itself, right? So this message is nothing but the message what we are passing from render template, right? So return render template index.html. This is the message what we are displaying in the web page as message here, right? So I think I have explained, and this index.html should be placed inside the templates folder in client side validation folder, right? So now let's start executing this program. Okay, now let me show you how I have executed this program. So first I have went through this application security lecture. Within that I have created CD validate client validation, right? So I have moved to change directory to client validation, and then I have created a virtual environment. It is not mandatory, but it is advisable to create a different virtual environment for your different projects. So that is what are represented here as a Python hyphen m virtual environment VENV. And then next what I am going to do, I am going to activate the scripts which are represented in the virtual environment. Then so while I have started executing this, Python flask is not available, so it has represented the error over here. So I have used pip install flask to execute to install flask, and after that I have started executing this app.py, which is nothing but which is available in this folder, right? So this is app.py. Within that we are having templates. Templates will have index.html file. I think now you got it clear, right? So but after start executing it, it is started and running in this particular URL. So now I have stopped it. So what are the things I have represented? I have represented four get request, and after that I have posted the content whatever I have get in this name, email, as well as the submit button. Once you have click on that submit button, it will render the message what I have passed as name and email, right? So that is what post method usage. So now once again I will execute it and show the content to you. Python.app. So once again it started executed. So now it start executing and it is available in this URL. So let me go to that particular URL, right? So can you able to see that client side validation example, and label is name and text is name. Similarly, label email, text is also email, and I am having one submit button. So now let me give, so here only validation what I have mentioned, it should not be null. So it can also have a numerical value or it can have a string value, but it should not be null. That is the only validation I have checked. If you want, you can include different validation, like it should not be null, like that you can include several validations, right? And then I'm giving an email here, and if I submit, it is showing received message, right? So if I am not giving any value here and just an email over here, what it is showing, it is asking me to fill out this field because it should not be empty. That is what we have checked in that script, right? So similarly, if I am not using at symbol, which is I have validated in the client side code, if that symbol is not available, it will first asking to fill the field of name. So just I'm giving Devi, and so please include an at in the email address. This is missing, right? So you have to use an at symbol, submit, right? So Devi, and this is the name and this is the email ID which is rendered after the post method, right? So this is how we are executing a simple client side validation. Only two validation I have done. I have not checked whether it is numeric or string. Only I have checked it should not be null. Similarly, in email, I have checked only at symbol is available or not. But you can include dot everything. Domain name is there. Everything should you can check over here. But it is not going to add any advantage to the security. But it is for user experience and better performance, right? So with this, let me complete today's session. Thank you.